You've made it to the final base. Bottom the knife, 2 outs, but this time it's not about stealing the base. It's about changing them. In today's video, we will not just be switching coordinates, we'll be switching the very axis they live on. So in this video, we're talking about the change of bases in linear algebra. We will talk about different coordinate systems and how to use the change of bases. We will even work through an example where we apply these concepts. And a vector coordinate depends on the basis you're using. When you want to switch to different bases, that's when the change of basis comes in hand. And it lets you translate these coordinates from one basis to another. Think of your usual coordinate system we're all used to, the x, y, z axis. So you have your x right here, y, z. This is a form of a basis right here, just the one we're familiar with. We will actually notate these by using, we can use, we'll just use B1. So you have B equals, and you have B1, B2, B3, and you know what these are going to look like. It's going to be B1 is 1, 0, 0. B2 is equal to 1, 0. No, it's going to be 0, 1, 0. And then the B3 is equal to 0, 0, 1. And this diagram, or this demonstration here, is just to give you a good idea of what bases are and the coordinate systems that they use. The difference between our standard basis here that we're going to be naming this, and let's say like a basis in B, it's going to be a little bit off from what we're usually expecting. So let's say you have C1, C2, C3, and as you can see, it's just a different coordinate system. And in this video, we will be able to show you how to transform in between, let's say, a vector in C and the C basis into the standard basis, and so on. You can also, and that's going to be the main idea of today's video. All right, just as the standard basis showed us a good idea of what we're looking at. Let's suppose we have some vector. So you have b equals, and then we're gonna have b1, b2. That's a terrible b. And then we have b1 is equal to 2 over 1. And then we're going to have b2, which is equal to 3 over 1. And now we want to find the change of basis matrix to convert this to the standard basis as we showed from before. So how we're going to write this is the standard basis equals the transformation matrix here, which is going to be notated as just as B, and then this is going to be our vector in B. So we have this in brackets and then a B on the bottom. So what makes up this change of basis here is when this example, when we're trying to go from this non-standard basis of B to our standard basis, it's really just the two vectors of our non-standard basis B. So to find this, it's going to be PB equals 2, 1, 3, 1. As you can see, it's not too bad. Now let's say we have a vector in B that we want to transform into standard coordinates. So B equals 4 over 1. Now let's transform from B to normal coordinates. We know how to do vector multiplication from a vector to a whole. it's just going to be the 4 times the first vector here and the 1 times the other vector to get, and then we add them as you would expect. So x1 equals 4 times 2, 1 plus, and then we're going to write a 1 here just to show the idea. We're going to have 3, 1, which is going to equal 8, 4 plus 3, 1. And this is gonna this is gonna be in standard coordinates in the form 11. Is that 5? Yeah, 11, 5. That looks right. And that gives us a pretty good idea how to go from a non-standard basis, like a vector in a non-standard basis, to a standard basis, applying this idea. Let's say you want to go backwards. This change of basis matrix is invertible. So we're just going to write it as, let's say you're given let's say you're given a vector in the standard coordinates, and you're trying to go from that to a vector in the non-standard basis b. You write it as the inverse of our transformation basis times x is equal to our vector in the B matrix. Just like that. It's not too hard, not too bad. Now we will find another way to find the change of the basis matrix. Let's say if you're trying to transform from a non-standard basis B to, or let's say C to a non-standard basis C, and this will use a different formula and we will be using row reduction in this example to find this change of basis matrix between the non-two standard bases. So you notate it as our vector in C is equal to our change of basis matrix right here from B to C, as you can see, and then this is going to be your vector in B. Actually, in this specific example, we're trying to transform matrices, so these two are going to represent a matrix in between the two, so that we can find this one right here. So let's say, let's write some notation so we can kind of understand what's going on here. So you have C1, which is it's going to be a basis, which equals right here C1, C2, and then you have your basis B, which is going to be B1, B2, and then you're really just augmenting these two to find this change of basis matrix right here, and then you're going to move from this left side to the right side, and the kind of idea is you kind of take the inverse of that left side, which gives you the identity matrix, and then you're left with that. You're left with the change of basis matrix that we're seeking. We might change these around in our actual problem here. I think that's going to be the idea. So now that we have a good understanding of what we're doing notation-wise, let's say we have two bases in R2. We're going to have B equals B1, B equals B2, and then we're going to have C equals C1, and then C2. B1 is equal to 1 over negative 3, and then we're going to have B2, which is going to have negative 2, 4. Let's do these brackets. And then we're going to have C1 equals, we're going to say negative 7, 9, and then C2 equals negative 5, 7. So we're going to find the transformation matrix going from, let's say, C to B for this example. So we're going to write our notation here to get a good idea of what we're going to do. So you can always start with the change of matrix, basis matrix to get a good idea of what we're doing, like which go where. So you go from B to C, and that gives you a good idea where they're going to go. So you're going to write on this left side, it's going to be the C matrix, and then on the right side, it's going to be the B basis right here. And that gives you a decent idea of what we're going to start doing. We're going to augment those two. So you're going to have, oh, what did I say? We're going to go from C to B. That's what I meant. Yeah, that makes complete sense because that's a lot easier. As you can see that the B starts with a 1 in the top. If you want to solve this, you definitely want to do this way first. And then we have this. So you have 1, -3, -2, 4, augmented with -7, 9, -5, 7. And then you're going to do your row operations. So you can find this p vector here, and you should be expected to have like 1, 0, 0, 1. And that's supposed to be 1, my bad. And then you're going to have something here, which is going to be your change of basis matrix. Now that we got the change of basis matrix down, I'm going to just show you a diagram to visualize the kind of transformations we can explore from here. So feel free to like take a screenshot. This is a good idea to have an idea like we're going from where to where. So if you're going to go from, let's say, our L vector to our standard basis, you multiply it by the change of coordinates basis here to get our standard coordinates, and so on. It's a pretty good illustration of our process here, and it helps us out if you ever like take notes on this. And I think that really concludes all the topics we're covering today. Thank you for watching. In the next video, we will be discussing a different topic, how to schedule tasks on Linux using cron. Let's say you want to reboot your computer every day. That's what it's for. And don't forget to like and subscribe to motivate me to make more content. And thank you and have a good day.